Hello everyone, welcome to day 17 of competitive programming of 365 days. Yesterday we have solved two questions from the contest 79, and today we'll be solving two questions based on reading, and we'll solve tomorrow two questions or few questions from the before contest. For now, let's start our timer and let's open CoachF. In this we were practicing, and I guess it's in page 2, right? Page 2, yeah, parallel processing, and I guess one more is equal mix splitting. Yeah, here it is. So let's go to CB directory, and now okay, we have solved quite a few questions. 1 2 3 4 5 and 1 2 3 4 5 6 7. Roughly those are 35 and minus 2, 33 questions, I guess. Let's count. Yeah, 33. Anyways, now let's solve this question. Let's open Autumn, and the code is PLP RO process PL process.cpp. Yeah, actually we came up with this solution yesterday. I'll provide the yesterday's videos link in the description also, and compiling, giving this output. We got 6, 3 and 5. Okay, we got 6 for some reason. We're gonna check it. Why? So the first array is having size of 3, 4 to 3 are the values. We'll be printing f equal to f value and s equal to and this value. Let's clear, let's compile. Okay, that printing in this way really helps me to understand what actually is happening. So initially f is 0, s is also 0, 3 4 5. Why are we getting 6? What about the 4 value? Why are we not reading the 4? Okay, let's just move that thing here. Now if you run 1 3 4 2 3, we are adding s. 2, we are adding 3. Okay, we are sorting, then we went near 4. If we add 4 here, we'll get 7. Okay, my approach was we'll actually sort the array and we'll add the values to the one which is which processor is doing less time task. We'll give task to that processor, but apparently we cannot do in that way. So first we'll give the maximum value. So sort in reverse or reverse. Actually, how did search for that? I need to remember how to do it. So here it is to sort in increasing order, and in decreasing order it is one more parameter, the other parameter greater int. That's it. Okay, we are passing a function greater int. Now let's compile. Let's take all the values. Okay, here first we'll add 4, then we'll get and we'll add 3 for the next processor, then we'll add 2 for it. Similarly here, adding them, finally we'll get 3. Here we are getting 5. So let's remove this line, shift and backspace. Okay, let's copy all this and let's paste it here. Let's run for now. Okay, it's running and we got the correct output for the sample test case and sample input. On submitting, here the constants value is also less, so first and the last test cases are accepted, but the middle ones are not accepted. So here a of I is 10 power 5. So since a of I is 10 power 5, our f and s values may change, or int will not sufficient. That data type may not be sufficient to hold the values, so we'll be changing for ll, and which means long, which we have defined. Okay, let's try this time. Currently running test case 2, and test case 4. Yeah, we got the wrong answer. So what is the thing we are missing here? Time in which a task can be executed. So if f is minimum, if this is true, then it should be f. If it is not true, then the answer will be yes. So answer should be the minimum one, right? So g++ process. Let's copy all this thing. We got 430. How is that possible? Say first and task 1 to the first processor, no task is executed by second processor. Okay, second processor will be times 0. So that's the reason we are printing 0 here actually. And even here it is 3, so we printed 3, and here it is 4. Okay, though we are printing the minimum time taken, we need to since we are printing the minimum time means we need to find a way to divide the numbers whose sum will result in minimum, but not print the minimum of them. So this logic here is correct. Whatever the maximum time out of the two processors, which processor is having more time, we need to print it, but we need to try to reduce that more time value. Okay. what am I missing here? Let's take numbers from 1 to 10 for our understanding. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I have sorted it in increasing order, right? Decreasing order. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Now for processor 1, inside this, since f is less than s, we'll add f10. And now since f is greater than s, for the next iteration, okay, we'll be adding s9. Now still 10 is great, it will be 18 since we are at 8. Now adding 7 here, it will be 16. Now we'll be adding 6 here, so it is 24, and adding here 21. Now f is not smaller. Sorry, this is f value, this is s value. First comparison, f is initially 0 and s is also 0. F is less than s, it is false. Since 0 is less than 0, will be false. And here is the live proof here, it is false. Okay, we need to give exit function. Next we are having, since it is false, we'll add it to s. So here it will be 0, here it will be 10. F is less than s, true, so 9, 10. F is less than s, true, so it is 17 and 10. F is less than s, false, so 17 and 17. 17 is less than 17, false, so it is 17 and adding 5, 22. Okay, we need to add 6 right now, right? So it is 23. F is less than s, true, so 17 plus 5, it is 23. And 23 is less than 23, false, so 23 and 4, right? If we add 4 here, it will be 27, true, 26, 27, 28, 27, and then we'll add 28 here. Wait, 1. So first 5 numbers, 1, 2, 3, 4, 5. So let's say pattern 3. Let's say 10 plus 9 plus 8 plus 7 plus 6, it is equal to 40. 5 plus 4 plus 3 plus 2 plus 1, this is 15. Since this will be false, the value will be having 28, so the answer will be 28 here. That's it, right? Okay, I forgot to remove all these values. 10, okay, only one test case. 10 values. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Yeah, we got the answer 28. For what values we are getting wrong answer? What could be the edge cases, edge test cases? Well, it is the big part of solving all the questions. We are able to solve the given sample inputs but not able to solve hidden test cases. Let's convert all of these to okay, here our answer variable should be long, right? I guess that's the mistake. That's the value I didn't change to long when I've changed the fns to long from int. Is it still it's wrong. Okay, actually one got one of the test case is cleared and the only test case that is not cleared is this. Actually largest value of int, it is 1 2 3 4 5 6 7 9 10. So it is 2 into 10 to the power of 9. And long to 10 to the power of 9. So still 10 to the power of 5 we can have them in an int. So it's not necessary to change this to long, but still let's do it. Let's just change all let's just only use long instead of int. From now let's just use a long data type instead of int. Well, I was under the impression that if the numbers are less, why use long if we can use int? I think still it is best to use based on the requirement instead of just overkilling. Okay, there must be some logical mistake in our code to pass the second test case. Let's read the question to see whether we have missed anything or not. There are n tasks waiting in line to be executed. The execution time for the ith task is AI seconds. Chef has 2 preprocessors to execute these n tasks. Both these preprocessors work simultaneously. For each processor executes the assigned tasks one by one. Chef assigns a prefix of these tasks to the first processor and the remaining tasks to the second processor. For example, if there are 3 tasks, Chef can do one of the following. Assign no task to the first processor. This means the second processor will execute task 1, 2 and 3. Assign task 1 to the first processor. This means the second processor will execute task 2 and 3. Assign task 1 and 2 to the first processor. This means the second processor will execute task 3. Or assign all. Okay, it should be in the order, right? So we should not sort it. Let's just compile. Well, sorting is the mistake there. We still got 5, 3 and 5. For let's think 10, 1 and 0, or 10, 1 and 5, 5. If it is sorted, it will be 1, 5, 5, 10. So we'll add 1, 2, yes, 5 to second, F, and 5, 6 here, and 15. Okay, if you are not sorting, actually one more test case is being failed, which was passed before. So we need to sort. Okay, why is that happening? Let's just say even if it is equal, we'll add to the first test case, and even here if it is less than or equal to s, we'll go with s. Here actually I think it doesn't matter, and we'll be sorting, but let's sort in increasing order itself. Okay, here we are doing more like trial and error, because logical I couldn't think of any mistake in ordinary part which we have missed. Yeah, most of the test cases failed, but the third test case did pass. Okay, it may be because of equal to sign. Let's sort greater int a function, right? Currently running test case 2 for now all the test cases got passed, but the second one got failed. In before case, in before case second one got passed? Okay, or the third one got passed? Cancel. Yeah, only third one got passed. In either case, second one is not being passed. I thought second one got passed here. So we are sorting it actually, and we'll add the maximum value first to the we'll give maximum value to the processor, then we'll be assigning the negative processor values to the processors. That is the logic here. I'm just thinking, yeah, what is the mistake we are doing? Because one complete test case is failing, either way we just solve it. We are taking the arrays I mean reading the values starting from the maximum value. Well, here we are having three different cases. First case is let's assume only n is only 1, so this is the only value, so we'll print okay, that is also being handled here. Next, if n is only two values, they will print the maximum of those two values. In next case will be we'll be adding alternatively, or we'll be adding to the processor which is currently running in less time. Shall we look into the submissions, because we have spent half an hour time on these questions and there is one edge case we are failing, so understanding the submissions may help us to see what is happening here. Okay, he just did the thing which we discussed recently, that is if n is equals to 1 will print if n is 2 will print the maximum of m. Then calculate prefix sum. We'll start from I is less than, then we'll add the calculate suffix sum long int. Okay, here we are finding minimum difference in all the pairs and storing the time of where to break. Okay, this seems very complicated to me. Let's go for a different submission. C++ 14. Yeah. Okay, even here if it is 1, 2, then he is maintaining two arrays and the okay, he is maintaining two values actually. Did he sort the array anywhere? Actually, he didn't sort it anywhere. Vi in the sense is vector int. We took an array. Okay, next, if I is equals to 1, j is equals to n minus 2. While I is less than or equal to j, if p1 is less than or equal to p2, then we'll be adding to p1 and increase the I value. Else we'll add to the p2 and decrease the j value. And yeah, this is what we have done actually. But in for loop, we are taking 1 value. Whichever processor is running low. Here P1 is the processor 1 and P2 is the processor 2. He instead of adding 0, he took from the first element and the last element, and I is starting from the next of first element, that is instead of 0 is starting from 1, j is starting from the last second element, that is instead of n minus 1 it is n minus 2. Okay, which our process is running now will, yeah, that's what I have done. But he didn't sort it anywhere. Instead of p1 p2 I have taken first and second. If p1 is if I mean s is less than or equal, f is less than or equal to s, we'll add that element to the first, else we'll be adding it to the second. So what is the difference here actually? Let's take the same array, 10 9 8 7 6 5. Okay, it's enough. We'll change these values to 1 2 3. Now we are having totally different array. So first, according to his code, he will add 10, p1 is 10 and p2 is p1 p2, this is 10 and this is 5. So initially I is at index 1, that is its value is also 1. So since p1 is not less than or equal to, so we'll add j, which is 6 here, so it will be 16 and this is 5. Okay, we'll add sorry, here it should be added to second one, right? p2 will add array of j, so 6 will be added here, level. Since it is less, so it is level. Here I am having, I will add 3 here, which is 14. Okay, here it should be level itself. Is so we'll be adding 2 is also to level, since x change from I is 1 to 2, which is also having value 2, so it will be 13 and here will be level. It's not greater, so 3 will be added here, so 13 level and level plus 3 14. Now all the values are completed. In my case, what is happening is, okay, the array will just change to 10 6 5 3 2 1 and I'm having variables f and s. Let's just have them here, fs. So here f is actually 0 and 0. Since 0 is less than or equal to yes, so we'll add 10 here, 0 here. Since 10 is not less than, so we'll be adding here and here one more time. We'll add 3 here, so it will be 13 on level and 13 and 13. We'll be adding 14 somewhere like here itself, so 14. Maximum of these two is 14, we'll print the 14. Maximum of these two is 14, we'll print the 14. So where is my mistake? If only two numbers are given, like 5 and 4, we'll add 5 to the f1, since in the next iteration let's take 5 and 4. It is sorted. So now since f is 0 and s is also 0, f is less than or equal to yes, So we'll add 5 here, 5 0. Now f is not less than, so we'll add 4 there. It will be 5 and 4. What is the thing I'm doing here wrong? So where am I missing? I'm printing the maximum of these two. F is less than or equal to yes. So here it will say false. So f is 5. So 5 will be printing. That's it, right? G++ process a dot out 1 2 5 4 5. Okay, let's just take this part of code. Let's copy it. Let's comment this thing here, and also okay, we need not solve also. Paste here, comment this and this. Let's take copy everything and let's see whether our test cases are being passed or not. Before that, let's also compile in our terminal. Okay, we got 2 errors. They say these values are not declared, but they are declared here. Sorry. In line number 19. Okay, it's not a, it's AS, just I. So now let's compile. Yeah, everything is works well. Let's just bring our terminal here right now. A dot out. Yeah, we got right answer for all our sample input and a sample output. We got expected sample output. Let's submit this now. Currently running test case 1. We have 4 test cases. Yeah, now it's correct. Okay. What am I missing here? Okay, let's say answer is maybe this max of first comma last second. Okay, let's remove this part here now. Okay, later let's print max of first and second. Without even sorting, he got the right answer. Let's compile now. Copy 535. Let's take this. paste here. Let's say submit. Current running test case 4, and it's a wrong answer. Our second and fourth are not being submitted. Why? Here is the first and the second. Okay, there is something to do with this prefix and yep, just prefix in the sense at the end, right? So we are only going from first starting itself. So okay, Chef has two processors to execute these n tasks. Let's just close these two. N task. Both these processors work simultaneously. Each processor executes the assigned task one by one. Chef assigns a prefix of these tasks to the first processor and the remaining tasks to the second processor. Okay, post prefix suffix. Prefix means starting point to the first processor and the remaining to the second processor. So second processor will not take any processor from the start of the array. So it will take everything from the end. Okay, is that so? So should I change it to n minus I? Let's compile. The test cases are these. Okay, we got the same answer here. The question is, will it get submitted? So any processor you are going to add to the second processor, it should be from the end. That's it, right? Yeah, it's still the wrong answer. N minus I should go from n by 2 itself. Less than or equal to n by 2. Because here we are doing n minus I, right? Okay, now 3 test cases got failed. Okay, I understood the point that if first task we are assigning to the first variable and the second task we cannot assign to the second processor. You need to assign, okay, first half of the task should be assigned to the first processor itself, and second half of the thing should be assigned to the second processor itself. Okay, that is how he has done this here such beautifully. Shout out to him. So there is the logic. That's the there I am failing, right? This prefix word, ignoring this line, I kind of ignored it. Okay, now I understood what happened actually. So here this code is couldn't understand it properly, so let's just say change it. We have f equal to 0 and s equal to 0. First let's remove it, and while we need to maintain two variables, let's maintain I comma I equal to 0 and j equal to n minus 1 starting from the last, while I is less than j. We are gonna do, okay, it is less than j, right? Or it should be equal. Where is okay, it must be equal. Let's get all the code back. I is less than or equal to j. Sorry, if f is less than s, and the else case. We'll add the first element of a of I and we'll increase the I value. Okay, we can do that in one line itself. I just want to remove those braces here. Yeah. If f is less than s, then I will add the first element. Else, I will add to the second processor, but I will add the last element. And I'll print the maximum of the both processor values. That's it. Submission is queued. Okay, I got a submission ID, but is it correct or wrong? Let's compile PL process. Okay, we have all our time is trained in this question itself. 535. Let's submit it one more time. Okay, we are getting our submission IDs, but view all submissions. Okay, it is still running. Is the while loop not ending? Is that what is happening? For the test case 4, maybe the while loop is not we are increasing the I, reducing the j. Okay, it is the correct answer, but here, yeah, it's the correct answer. Let's reload the page. Okay, this is my submission, right? It is correct. Yeah, it got submitted. Okay, should I explain my code here? Explain my code. From line 12 to 15. The thing is, we can only add processes to the second processor, that is S. Okay, second and second, both the spelling is correct, same I guess. To the second processor only from the last. Does that make any sense? Okay, for now will not explain. For now, let's leave it in this way. That's it. That's the only mistake we were doing. The only mistake was that we forget about the. Okay, on second thought, I want to explain the code. Okay, line number 12 to 15. Though my explanation would may be bad, but I will be add processes. I will be improving. Add processes to the processor which is whose value is less, and we can only add processes. Okay, we can only add task. Let's say task. Too many processes, processor, processing words. So, and we can only add task to the second processor only from the last. These are the only 2 points, right? That's why we maintain I and j values. Let's create. That's it. Let's close this. And how many more minutes? And how much time we are having? We are having 10 more minutes. So let's read this equal max splitting. Chef has an array A of length n. Chef wants to select some disjoint non-empty subarrays from A such that the mix of each of the selected subarrays is the same. Note that the selected subarrays need not cover all the elements of the array. Okay. For example, then one way in which Chef can select subarrays is as the here mix of both of them is 2. Chef wants to select the maximum number of disjoint non-empty subarrays that satisfy the above condition. Can you help him to do so? Okay, basically we'll give the array. Then I will need to say how many number of arrays we can create with the equal max values. That's it, right? Yeah, that's it. So I'm thinking of a way. We give us 0 and 1 and 1 0. Okay, should we maintain a map here? By the way, I'll shortly explain what is max. Max in the sense okay, I forgot the full form of max. Max is nothing but if an array is given, it is the maximum of it is the minimum number, that minimum natural or whole number that doesn't exist in this array. 0 and 1, the minimum whole number is 0, right? It does exist in the array, and after 0 1 is the next minimum, which is also exists in the array, but 2 is the next minimum and it doesn't exist in the array, so 2 is the max. Here 0 is the minimum element, it does exist here. 1 is the minimum element, it exists here, and 3 is the next minimum element. I mean 2 is the next element, I'm sorry, but 2 doesn't exist here, so 2 is the max of that answer. But if you take an array like okay, let's say 1 2 3 4, here max will not be 5, it will be 0 because 0 doesn't exist here. Okay, let's have 0 1 2 and 4 5. Here max will be 3 because 0 1 2 are the minimum elements that are already existing. Next minimum element is 3, that is missing. So that is what max is actually. Well, this is quite an interesting question. Okay, for now let's create. Shall we create an file here? Because we are having 5 more minutes. Okay, let's try. Atom max split. Here in the URL itself you can see the code for the problem code without expanding here. So .cpp, and now let's take the input. Reset the profile, and a of I is less than or equal to the number of the size of the array. So it cannot be, if the size of array is 6, number cannot be 7. Okay, how can we do this? I'm thinking that we'll maintain a map and we'll calculate all the frequencies of the elements. Once the number is used, we'll subtract one from it, and also we'll write a function max for which we'll pass the n value and the array. Well, it doesn't work actually. Okay. So today let's summarize the day. How many questions did we solve today? We just solved one question that we have started yesterday. Actually, yesterday we have solved two questions, I guess. Today we just solved only one question. Okay, opened it by mistakenly. I need to spend, I think it takes, I'm not getting any idea apparently right now to solve this question. Okay, we'll conclude this. We'll try this question tomorrow, and after these we'll be solving some greedy algorithm questions. Do we have questions in greedy algorithms for our rating? It is 1400 to 1500. Yeah, there are like 8 questions. We'll finish all these 8 questions. Our goal is to finish all these 8 questions. And in dynamic programming, I guess there'll be a lot. Yeah, there are a lot. Okay, actually, but not in our dynamic programming. Okay, well, there are only 2. Wow. Okay. And in data structures, again we need to have our 1400 to 1500 range. There are quite a number of questions. There are like 30 questions, right? So we'll be solving greedy algorithms and dynamic programming questions in our rating range, and in data structures we'll solve few of them. And what about binary search? Okay, there are none. And in sorting, there are few in sorting, and 2 of them are based on max, I guess. Okay, anyways, thank you everyone. We will end this here, and all the code will be available in my GitHub repository, and I will provide its link in the description also. Thank you.